Welcome, everyone. We'll be waiting 2 to 3 minutes to get started as a courtesy to those who are still in the middle of connecting. Welcome, everyone. Thanks for joining us and thanks for being part of our community. We have a great topic to cover today, but first, a few reminders. Please feel free to ask questions at any time by typing them in the IM window. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars and we'll do our best to respond to all of them in real time, but I want to provide an additional mechanism to ensure any questions you miss get answered. And any questions that we miss get answered. If you'll visit aka.ms/Azure DDoS community, you'll be able to ask questions on our Azure DDoS forum. If you're listening to this after the fact as a recording, that's also a great place for you to ask a question. We always love to hear your feedback on whether these webinars are valuable and how we can improve them, and you can give that to us at aka.ms/security webinar feedback. And all these links that I'm referencing here are posted in the chat window, so look for them there. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security webinars. While you are there, please join our community by visiting aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products. You'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up for at aka.ms/security private preview, requesting features, giving feedback, reviewing our product roadmaps, attending in-person events, or joining webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. We have a great topic today. We'll be covering Azure DDoS. DDoS protection. So I'd like to introduce you to our presenter, Anupam Vij. He's the product lead for Azure DDoS, and so he has deep expertise in this topic. Without further ado, I'll turn it over to him. Anupam.
Thanks, Ryan. Hello, everyone. So yeah, we're going to talk about Azure DDoS Protection Service in Azure and how it's going to ensure that your applications are protected against DDoS attacks. Now, the way we'll go about this webinar today is I'll present certain slides and then we'll try to end it up with certain live demos. Anytime you have any questions, I strongly encourage you to put the questions in the IM window before it's too late or you actually forgot those questions. So with that, let's get started. Now, a very common question that I get asked on a frequent basis is like, how often do DDoS attacks happen? And what we see industry-wide and in Azure as well, that DDoS attacks are actually very frequent. And year over year, it's not only the frequency of the attacks that's increasing, but it's also the volume of the attacks that continues to increase. Now, it's also actually getting very easy to generate these DDoS attacks, while the complexity involved in mitigating these attacks is actually getting very high. Oftentimes, DDoS attacks are used as smokescreen, such that it's a distraction to your environment, while there's other malicious infiltration attempts that are being attempted against your business or mission-critical applications. Now, the other thing I would like to highlight is it doesn't have to be 2+ terabits of a DDoS attack to impact the availability or performance of your application. All it needs is a targeted DDoS attack against your application, which could be as small as like 50 Gbps, and that would be sufficient enough to impact the availability and the performance of your application. It's not a matter of if your application would be impacted by DDoS attacks, but these days it's a question of when it would be impacted. And hence, it's critical to understand what are DDoS attacks, how are you vulnerable against such attacks, and what actions and preventions you can actually put in place to ensure that you have the resiliency against these attacks. Now, towards the frequency and the volume of the attacks that we see in Azure on a regular basis, recently we have published the security insights for DDoS on our Microsoft website, where we kind of classify the DDoS attacks by the TCP protocol and the UDP protocol, and we highlight on a regular basis how many attacks are we mitigating in Azure and what is the volume of the attacks that we are mitigating. And as I highlighted, it doesn't have to be a huge DDoS attack. Oftentimes, the questions also comes in that DDoS attacks probably only happen during the holiday season. With this data, I think it's it kind of provides that visibility that it doesn't have to be the holiday season. You can't predict at what point an attack is going to happen. We have seen that the Memcached attack that happened last year, which was one of the biggest attacks ever known to the mankind, 1.7 terabits per second, that happened around the Feb-March timeframe. So DDoS attacks are frequent. They happen throughout the year, not only just during the holiday seasons. Now, before we go into details on Azure DDoS Protection Service, one thing I would like to provide a bit more clarity on is how we classify DDoS attack types and why it's important to know that. The DDoS attack types are often classified in 3 different categories: volumetric, protocol, and resource attacks. Now, volumetric, as the name suggests, usually involves huge amount of traffic that's being sent to your application such that your application stops responding to the legitimate client requests. The protocol attacks often leverages some vulnerability in the application or exhaust the state tables or the state flows of the networking devices with the same intent such that your legit client connections should not be able to connect to the application. It could be just the network congestion that happens, or it could be that the application itself has taken a hit in terms of the availability. The volumetric and the protocol attacks are also known as the network layer attacks because they inspect or they happen at the network layer, which is layer 3 and layer 4. Resource attacks are different. Resource attacks, what really happens in the resource attack is that the application vulnerability is exploited. And to prevent against those attacks, we recommend to deploy a web application firewall. Whereas the DDoS protection service works against the volumetric and the protocol attacks, which is the layer 3 and layer 4. Now, the reason is because as we are doing the DDoS mitigation, and I'll go more in details in the upcoming slides, we only inspect the packet header. We don't review the packet payload. And further, the reason is because in order to inspect the packet payload, we have to do the SSL offloading, which means we need to decrypt the certificate, which is the SSL certificate, and the DDoS Protection Standard service doesn't do that. In order to maintain high throughput and high performance as we are dropping the traffic. With that in mind, let's take a look at some of the key pillars of the Azure DDoS Protection Standard service and why it's critical to protect against the DDoS attacks against your applications. For each of these bullet points, I also have like dedicated slides where we're going to go into details. This is just to provide a very high level overview. So the first thing is that the Azure DDoS Protection Standard service is completely integrated into the Azure Global Network. We leverage the global scale of Azure software-defined networking such that we automatically detect and mitigate attacks wherever they happen across our Azure region. We are available in 54 Azure regions. We also provide with DDoS Protection Standard adaptive tuning, where for each application that is being protected, we understand what is the normal peacetime traffic volume looks like for your application, and we immediately detect if there is a suspicious activity happening against your application that could be a DDoS attack. If we do determine it's a DDoS attack, immediately we'll start doing the mitigation without you having to take any extra action. And as we are doing the mitigation, we also provide rich metrics as well as attack analytics, such that not only you understand that your application is under attack, but you have further insights with respect to the traffic that we are dropping, the traffic that we are forwarding. And you can also do the integration with your online or offline SIEM systems for any deep analysis or to train your security operations team. We do understand that DDoS attacks can be very critical to the availability and the performance of your business or mission critical applications. Now, majority of the cases, as we detect an attack and as we do the attack mitigation, you don't have to take any action. We take care of the mitigation automatically in the backend. But there could be always corner case scenarios. And towards that, anytime if your application is under attack and you need support from Microsoft, you can open a survey case and immediately within less than 15 minutes, our engineering team will work with you to provide any white glove support service to understand what kind of attack mitigation needs to happen to even more effectively mitigate the attack. Again, for each of these bullet points, we have dedicated slides that I'll talk more in details. And lastly, we provide the SLA guarantee and the cost protection as your application is under mitigation when it is under attack. So let's talk about the adaptive tuning. Now, in order to onboard to DDoS Protection Standard, you need to enable it on the virtual network. Now, even though from a provisioning standpoint, DDoS Protection Standard is enabled on a virtual network, the protection applies to the public IP resources inside that virtual network. The public IP resources could be a public IP of an application gateway, web application firewall. It could be an Azure firewall, load balancer, virtual machines, etc. Now, the way it works is that the moment you enable DDoS Protection Standard on a virtual network, automatically will identify all the public IPs inside that virtual network. And for each public IP, we define 3 DDoS mitigation policies, one for TCP, one for TCP SYN, and the third policy is for the UDP protocol. One of the key attributes in each of these policies is at what point do we think there is a DDoS attack happening against your application. And the way we construct that attribute is based on a proprietary machine learning algorithm, which takes in consideration the scale of your application, which means the number of virtual machines behind that public IP, as well as it also learns about the traffic pattern that's incoming to your application on a regular basis. And the way we do that is we start building a traffic profile for your application such that we understand how does the traffic volume changes every minute over minute. We understand how does the traffic pattern changes hour over hour, day over day, week over week, month over month. And if we give it enough time, we'll also understand the seasonality differences. Now, if we take an example, let's say that there is a web application that you're running inside the virtual network on which you have enabled DDoS Protection Standard. That web application receives somewhere between 40,000 packets per second to 50,000 packets per second. As we are building the traffic profile, we will understand that and we'll define a DDoS mitigation policy, say for the TCP/SYN protocol, closer to the regular traffic volume that we see incoming, which would be, say, 55,000 packets per second. Now, if suddenly one day the traffic volume goes above 55,000 packets per second, we're going to detect that as an anomaly, and we're going to announce DDoS mitigation for that application, for that protocol. Now, just because we put the application under DDoS mitigation doesn't mean that we will start impacting the legitimate client traffic. All it means is during the time of mitigation, we'll start inspecting all the traffic incoming to the application. And if we make a determination that the incoming traffic is malicious, we'll drop that traffic without it making any impact to the availability or the performance of your application. Now, as we are doing that, like all of this is done automatically in the backend. There's no user configuration that is required. You don't have to take any action either. These policy thresholds, as the traffic volume changes to your application, gets readjusted every 15 minutes. So once we have built the application traffic profile, we understand that 9 o'clock Sunday morning, the traffic volume to your application looks very different from 9 o'clock Monday morning, potentially. We understand how it changes every minute. And taking that in consideration, every 15 minutes, we will adjust the policy thresholds that we have defined for your application. Using the Azure Monitor, we also provide you visibility with respect to the policy thresholds that we have set, which I would cover under the demo section. Now, talking about the global scale of Azure DDoS Protection Standard, anytime we build a data center or we build a new region, the DDoS Protection Standard service continues to expand in terms of the mitigation capacity that we offer. Our global mitigation capacity is 30 plus terabits per second. Now, why is that important? It's important because, number one, with this much of mitigation capacity, not only we can mitigate the largest attacks ever known to the mankind, but we can mitigate largest attacks of significant volume, but also multiple attacks all at the same time, and ensuring that your applications always stay protected anytime they are under DDoS attacks. DDoS Protection Standard service is designed into the global network. We are available in 54 Azure regions. The other interesting thing to highlight is that the traffic actually never leaves the data center, even when we are doing the mitigation. Now, the way it happens is, let's say that you have deployed the application in Singapore region. Now, when the attack starts, in order to ensure that the latency to your application or to the clients connecting to the application is minimal, we'll start doing the mitigation closest to your application, which would be, in this case, the Singapore data center itself. But if we do identify that the attack volume continues to grow, then we have a notion of initiating global mitigation, at which point we'll make the determination that if the bad traffic is coming, say, from US, we're going to drop the bad traffic in the US data centers without backhauling all the way to Singapore. And again, the whole idea is that the legitimate clients will still be able to connect at the same efficiency, whereas as we are dropping the bad traffic in real time, your application's availability and performance never gets impacted. The traffic stays within the Azure data centers and the Azure regions, which also ensures that we are good from a compliance standpoint. The other thing I would like to highlight here is that it's the same platform that provides defense against DDoS attacks for all of our first-party services as well. Example, Office 365 or Xbox. And gaming vertical is a top vertical that gets targeted by DDoS attacks. And with Xbox, we have seen and detected and mitigated every attack that you might have read in newspapers or in the news articles ever known very effectively. So we had that operational pedigree as well. Now, talking about the attack metrics, so we have done complete integration with Azure Monitor, Azure Diagnostic settings. So talking about the Azure Monitor, the snapshot here, so anytime we define the mitigation policies for your application, you will be able to view what those mitigation policies are through the Azure Monitor. So in this screenshot here, essentially what's reflected. For each public IP, we define 3 mitigation policies that continuously updates. And these 3 lines are essentially showing the mitigation policies that we have defined for TCP, TCP-SYN, and UDP protocol for a given application. Now, if your application goes under mitigation because we have detected a DDoS attack, then you will be able to see a metric, and I'll give a demo for that as well, where that metric value is binary. So the moment there is an attack on your application, the value would change to 1 from 0. You can configure alerts on those metrics, or you can even export any of these metrics to the storage account, or you can do the integration with Event Hub for further downstream integration to Splunk or any other offline SIEM system. The Azure metrics also provide high-level statistics with respect to the attack that we are seeing and mitigating against your application, like what's the total volume of traffic that's incoming, whether it's a TCP attack or it's a UDP attack, and how much traffic are we dropping and how much traffic are we forwarding. Now, we also provide another feature as part of the DDoS Protection Standard service, which we call as the attack analytics. And there are 2 features under attack analytics. The first one is the near real-time mitigation flow log. Now, in order to provide complete transparency with respect to the actions that we are taking while we are mitigating the DDoS attack against your application, what you can configure is, if you configure the mitigation flow logs, and this is supposed to be consumed in near real time through Event Hub, but what you would be able to view is the source IP, destination IP, source port, destination port, and the allow or the drop reason for not only the traffic that we are dropping, but also the traffic that we are forwarding, such that now your security operations team can do further correlation with respect to other activities that are happening in your environment. The other feature that we offer as part of the attack analytics is called the mitigation reports or the summary reports. And as the name suggests, the use case here is to kind of either build a dashboard in log analytics or integrate it with Azure Sentinel or Power BI. What we offer as part of the mitigation summary report is information like what were the top clients that were participating in generating DDoS attack against your application? What ports were being attacked, or if you had like multiple ports open on your application? What kind of attack vectors were involved? Because these days, most of the attacks are multi-vector attacks. And for each of those attack vectors that were involved, what actions we were taking and why we were taking certain actions. So you have complete visibility. We also provide information like what were the top countries or continents that were participating in the attack, including information like the AS numbers participating in the attack. Again, the whole idea is all of this information is actionable. So if you do determine that there are certain clients who are continuously generating DDoS attacks, you can go and blacklist those clients through the NSG. As similar for the mitigation flow logs, the attack summary reports can also be integrated with storage account, log analytics, or Event Hub. But the real use case scenario there is to do an integration with like Azure Sentinel or log analytics such that you can build a dashboard and you can present it to the executives. Now, on the DDoS rapid response, so as I alluded earlier, vast majority of the cases, we detect a DDoS attack automatically, and we'll do the attack mitigation without you ever having to take any action or reaching out to us for support. But if you ever feel a need, we do understand that DDoS attacks are very critical and can impact the availability and performance of your application. So towards that, if your application is under attack and you want to reach out for any support or any help, then what you need to ensure is that you select the problem type severity as critical, which is Sev A, and you highlight that the problem type is under attack. When you open a support case using this workflow, then within 15 minutes, and that's what we target from an SLA standpoint, our engineering team will work with you to put any custom mitigation policy configuration in place to mitigate the attack effectively if it is not being done automatically. Now, and I'll talk more in detail, in order to get the DDoS rapid response support, you don't have to onboard necessarily to Azure Rapid Response, which is yet another, I would say, kind of a support plan. And that support plan often, the price for the support plan is like $75,000 per year. But just by being part or just by being onboarded to DDoS Protection Standard, the rapid response support is available to you automatically for DDoS related issues. We have done integration with Azure Security Center, and there are like 3 key integration points. So the first integration point is the recommendations. Now, anytime if you have a web application, like whether it's an application gateway or it could be any other web application or a web application firewall with a public IP, and if it is not protected using DDoS Protection Standard, then we provide a recommendation through ASC that that's something that you should consider to onboard to. The same recommendation also integrates with the regulatory compliance, such that, again, if your web application firewall or application gateway public IP is not protected using DDoS Protection Standard, then we kind of highlight that under the regulatory compliance under the networking section. And lastly, once you're onboarded to DDoS Protection Standard, anytime your application is under attack that we are mitigating, without you having to take any extra step, we'll automatically send the alerts to ASC that we detected an attack and we are mitigating that attack. And once we finish the attack mitigation, we send another alert that the attack mitigation has completed. Now, here's a side-by-side comparison, and again, sort of a frequently asked question that what's the difference between Azure DDoS Protection Basic and DDoS Protection Standard? Now, DDoS Protection Basic is the infrastructure level protection. So anytime you onboard any resource to Azure or you create any resource in Azure, you get the DDoS Protection Basic protection. Now, think about the DDoS Protection Basic is to protect Azure region or data center from going offline if there is a large DDoS attack that happens. It doesn't guarantee that as we are mitigating a large DDoS attack against our infrastructure, your application's availability and performance will not be impacted. And the reason we cannot guarantee that is because it's only with DDoS Protection Standard that the mitigation policies that we define are tuned for your application's traffic volume. With DDoS Protection Basic, the mitigation policies that are tuned are for the Azure region traffic volume. So if we take the same example that we previously discussed, if your application receives somewhere between 40,000 to 50,000 packets per second, with DDoS Protection Standard, we'll define the policy threshold closer to that normal peacetime traffic volume, which would be 55,000 packets per second. But with DDoS Protection Basic, the policy thresholds would be defined at a much higher watermark, which could be as high as 300,000 packets per second, which means that by the time we initiate the basic mitigation, your application might have already been impacted. And again, it's only with DDoS Protection Standard that we provide the metrics and the alert integration. We provide the rapid response as well as SLA and cost protection. And I'll talk a bit more about the SLA and the cost protection in the upcoming slide. So talking about the pricing. Now, DDoS Protection Standard has a fixed cost and a variable cost. So both the costs apply. So let me talk about the fixed cost first. Now, the way it works is that in order for you to onboard to DDoS Protection Standard, you need to create a DDoS protection plan. Now, you create the DDoS protection plan in a given subscription, but it works across all your subscriptions in your tenant. So again, let's take an example. Let's say that in your tenant, you have 10 subscriptions. You create a DDoS protection plan in subscription 1. That subscription 1 on a monthly basis will be billed approximately $3,000. Now, even though you have created the plan in subscription 1, you can go to any of the other 9 subscriptions and link the same plan to any of the virtual networks that you want to protect against DDoS attacks. You don't have to go and create multiple DDoS protection plans. You only create the plan once. You use it cross subscription and cross geography or locations. And then there is a variable cost, which is the data egress on the virtual networks on which you enable DDoS Protection Standard. From that virtual network to the internet, that data egress has a graduated meter, which starts at 5 cents per GB and goes as low as 3 cents per GB. It doesn't account for the data transfer within the virtual network or within the Azure region or even across the Azure region. It's only from that VNet to the internet. And most often, that's very nominal. Now, the pricing includes so we provide the SLA guarantee that we guarantee that the DDoS Protection Standard service will always be available. And as we detect an attack against your application, we guarantee that your application's availability and performance will not be impacted. That's straightforward. But what we also offer is the cost protection. Now, usually what happens is that if there's a DDoS attack that happens on your application, and let's say that your application is configured to run on a virtual machine scale set, which auto scales, the initial burst of the DDoS traffic can scale out your resources. So let's say that the initial configuration was like 10 virtual machines. And as traffic surged because of the DDoS attack, those 10 virtual machines auto-scale to 100 virtual machines. With just being onboarded to DDoS Protection Standard, and given we offer the cost protection, you get the cost credit back for those scale-out resources. In this case, it would be the cost credit back for those 90 virtual machines that got scaled out. The same also applies for the data bandwidth, mainly the data egress. In case of amplification attacks, where your application starts actually initiating more connections to the botnets, your data bandwidth meter or the bill could surge as well. And by onboarding to DDoS Protection Standard, if that happens, you will get the cost credit back for all the surge traffic or for all of those scale out resources. So with that, I think I have like 1 or 2 more slides and we're going to move into the demo mode. But again, oftentimes the question that comes up is, I have deployed a web application firewall. Do we need like DDoS Protection Standard? Or, we have deployed Azure Firewall. Do we need DDoS Protection Standard? All these 3 products, the WAF, the firewall, and DDoS Protection Standard, these are complementary products. WAF provides layer 7 protection for your web applications. The Azure Firewall provides layer 3 to layer 7 protection and traffic filtering for outbound, and then layer 3 to layer 6 for inbound, because our recommendation for layer 7 traffic filtering is to put web application firewall. And then both the WAF or the Azure Firewall or any resource that is a public IP that's receiving traffic from the internet, at least on one given port, is susceptible to DDoS attacks. And our recommendation is to enable DDoS Protection Standard for those resources on those virtual networks. With that, we have published the best practices and the reference architecture guidelines on aka.ms/DDoS-best. Kind of highlights, if you have like multiple scenarios, probably running Kubernetes cluster, or you have a web application or a PaaS service, how you can actually, configure DDoS Protection Standard, and what are the best practices to ensure that the resiliency and the availability of your application is always maintained. So with that, what I'm going to do is going to minimize this PowerPoint presentation and switch to the demo mode here. So we'll start from the scratch here. So in order to onboard to DDoS Protection Standard, what you need to do first is to create a DDoS plan. So if you go to the marketplace and you just type in like DDoS, you'll see the DDoS plans here. And what you need to do is if you click on the DDoS plan, and I have one in my environment, but let's say real quick, I'm going to add a plan here.
Hey, Anupam.
Hey, Anupam.
I'm not sure that you're presenting the screen that you're trying to demo. I still see slides.
All right. Okay. Just a second. Can you see the screen now?
Yes.
Thank you.
Great.
Right.
Thanks.
Thanks for letting me know. So in order to create a DDoS plan, you need to just go search for DDoS in the marketplace. You'll see a DDoS protection plan here. And once you click on that, it will take you to this workflow, which is creating a DDoS plan. Now, what's really critical is the subscription that you create the plan in, because that's a subscription that will be billed like $3,000 per month. And once you create the plan, you cannot change the subscription. So that's the key piece that I'm highlighting here. With respect to the resource scope that you provide, or even the region, that's not critical. Like the plan works cross subscriptions in a tenant and cross region. So you can put the plan in any region. really a placeholder. It has nothing to do with where we even initiate DDoS mitigations. So with that, I'm going to navigate back because I already have a plan. And once you have created the plan, all you need to do is then you navigate to the virtual network. And on the virtual network blade, you'll have a DDoS protection subblade. By default, it's set to basic. All you need to do at that point is set it to standard, select the plan that you have created in your environment, and hit save. Now, provisioning is that simple. So once you hit save, automatically we determine what are the public IPs inside that virtual network. And for each public IP, we start defining those mitigation policies. We detect an attack. We are continuously monitoring for the attacks. And if the attack happens, we start doing the mitigation. Now, let me now navigate real quick to Azure Monitor or the metrics. So what I will do is go back here, my environment. So this is the public IP for the web application firewall that I am protecting in my environment. And what I will show here is you need to select public IP as a resource because the protection applies eventually on the public IP. And as I mentioned earlier, for each public IP, we define 3 mitigation policies. So you'll see that the mitigation, this is like TCP SYN mitigation policy for the public IP, which is the web application firewall. And given it's a demo environment, I only send like around 20,000 to 10,000 packets per second on a regular basis, which means that at any given point in time, if the amount of traffic exceeds above 20,000 packets per second, we'll consider that as a DDoS attack. We'll initiate the mitigation, and then we'll start inspecting the traffic in real time to see whether it's malicious. And if it is malicious, we're going to drop that traffic. So what I will do is using this Breaking Point Cloud portal, I'll start doing the attack simulation where I've specified the IP address of my web application. I've specified the port number. I'm generating a SYN flood here. And I've specified that the traffic volume is 100,000 packets per second. Now, the other thing I'd like to highlight here is that there are other metrics that you can review using the Azure Monitor. So one of the other metric is under DDoS attack or not. Again, a binary value. Anytime there's a DDoS attack, the metric value goes to 1. And then once the attack mitigation is completed, the metric goes back again. This is to provide visibility, just to highlight that your application is under mitigation and something you might want to ensure that you're not being impacted. Again, it's just for the visibility purposes if you want to use it. Now, as we do the mitigation, we also highlight in this case, like what is the total volume of traffic that we saw incoming and what is the total volume of traffic that we were dropping. So if I take a look at these TCP packets dropped, you'll see for that public IP, when we were doing the mitigation, like around 200,000 packets per second were dropped. And this is the amount, the same amount of traffic that I was generating using the simulation portal. Now, a couple of other things I would like to highlight real quick here that we talked about is, first of all, the integration with the security center. So over here, I'm navigating to ASC. And what I want to show you is that anytime we are doing the attack mitigation, where we detected that there is an attack on your application, then we automatically send an alert to ASC, highlighting an attack is detected that we are mitigating. Again, no action is required, but it's just for the visibility purposes. So here we highlight DDoS attack detected for a given public IP. If you click on that, you'll provide like basic information. We also highlight the fact that over here under the remediation step, that this is just as a FYI, everything in the backend is taking care of it automatically. And lastly, what I also want to show, because we talked about the attack analytics feature. So what I have done is for the mitigation report, I've generated a sample dashboard in log analytics. And we provide the sample dashboard through a GitHub account in our public documentation as well. But key things to highlight here is the information that it's showing here is the IP address that's under attack, the total volume of traffic that was incoming to that IP address, and on the total volume, how much traffic was dropped. In this case, I was generating a SYN attack. While we are doing the mitigation for the SYN attack, the first thing that we do is to challenge the client sending the traffic. And in this case, again, because most of the times when SYN attacks are generated, oftentimes it's coming from the botnets. The botnets don't respond to any challenge that you send them. And given they don't respond, we dropped all the traffic. These are the top computers that were participating in generation of the DDoS attack that's highlighted here. Again, something if you find happening on a regular basis, you may want to consider blocking through the NSG policies. And the other information that we are showing is what were the ports that were under attack, as well as like what actions we were really taking as we were doing the mitigation, and why were we taking certain actions. So in this case, we determined that it was a protocol violation, it was an invalid TCP SYN packet that we dropped. Now, I generated a very simple attack, but most often, like when it's a real attack that happens, you'll see there would be multiple vectors and multiple attack protocols that were involved. So for each of those attack vectors that were involved, you will find similar information. So that's pretty much it from a demo standpoint. And I'll go back here, which is the final kind of a takeaway, is that any application that's receiving traffic from the public internet on at least a given port, it's susceptible to DDoS attacks. DDoS attacks happen on a very frequent basis. And our recommendation is to ensure that you protect it using Azure DDoS Protection Standard. With that, we'll be happy to answer questions if there are any questions. And I'll leave you with this slide.
Great, thank you, Anupam. So folks, this is your chance here to enter any questions in the IM window, and any questions that you type in there, I'll read them to Anupam. And if you have something, that's you want to see a more detailed demo on kind of a part he was covering and explore that a little bit, that's valid too. You can say, walk us through this part a little bit more. So type those questions in anytime you've got them. So Anupam, can you tell us a little bit more about kind of the threat landscape? What are the most common attacks you see? Are, attackers still doing kind of old school SYN floods, or are most of the attacks a lot more sophisticated these days?
Great question. So we actually see almost everything happening in the wild right now. And I think the reason is because we find like attacks happening right from, someone like a script kiddie generating an attack to like very sophisticated hackers actually generating these attacks. So SYN floods are still prevalent. In fact, a lot of times now, the SYN floods that we are seeing happens from a full stack, like IoT devices. So given the rise of IoT, and we know how vulnerable these IoT devices are, what happens is that the old simple techniques of just challenging these botnets really don't work, right? So now we have to have like very sophisticated prevention mechanisms in place where we understand that even though the complete stack, the TCP stack is authenticated, there's still something very malicious about the traffic that's incoming. Apart from like TCP SYN flood, we also see a lot of UDP amplification attacks happening on a regular basis as well. And and again, these attacks, they may start as a TCP attack, but then the hackers or the attackers would then switch the protocol to like UDP and back and forth. So we see that flip-flop happening very often as well, where someone is trying to like hack you on TCP, and then if that's not going through, then they will try on a UDP, probably on a different port, probably a different vector, and all of this happens real fast with significant volume of traffic that's being sent to your application.
Okay, great, thank you. I've had a couple other questions roll in here. Can this be used to protect on-prem systems, or is this a cloud-focused solution?
It can be used to protect your on-prem system, but you'll have to do the hairpinning. By which what I mean is that what you can do is you can create a resource in Azure. The example again is like a public IP resource in the virtual network. So it could be like a load balancer, and you then redirect the traffic from that resource to your on-prem system, either through the public internet or through like ExpressRoute or VPN. So essentially what you're doing is that your application CNAME will now point to the public IP of the resource that you're protecting in Azure, and then everything in the backend will just seem to work. So yeah, it can be done.
Great. What's the competitive advantage against others vendor solutions?
Number one is first of all, like it's completely integrated into the Azure stack. And so, any features like Azure monitoring, diagnostic settings, integration with Sentinel, all of that comes almost for free. You don't have to manage like, different certificates or even have to worry about working with different vendors. The other thing is that traffic always stays within the Azure boundaries. So if we talk about like other competitive solutions, whether it's like, Akamai or Cloudflare, the traffic actually goes to their cloud and then it's a hop. So there are two things to worry about there. Compliance is for sure one. The other is it does add to latency as well. The third is the mitigation capacity. So our mitigation capacity today is 30 plus terabits per second, which is significant. And as we continue to expand our regions, we continue to add on to that mitigation capacity as well. And not to mention, it's the same platform. It's like a better tested platform because we've been providing the defenses for our first party services as well. which very few vendors can really talk about.
Okay, great. How do you manage false positives?
So the entire product or the entire platform is actually built towards ensuring that we are okay absorbing a lot of bad traffic. We are not okay dropping legitimate client connections. So all like the entire product is oriented towards it, where because given the scale of the Azure networking, we can absorb a lot of bad traffic that other probably like ISPs and vendors cannot. So as we absorb the bad traffic, we ensure that we are actually now inspecting of all the traffic that's incoming, whether we think it's really malicious, and we drop the malicious traffic. The other thing I'd like to also highlight is we never block the source IPs, which means that at any given time, if we think the traffic is bad, we are inspecting it and making a very conscious decision. Blocking the source IP usually means because the DDoS attack happens through botnets. So today that IP could be a bad IP, but tomorrow that could be allocated or reallocated to a legitimate client. So we don't do that for that reason. And third is we also never black hole the traffic, which means, again, we never indiscriminately start dropping the traffic. There are like very corner case scenarios, but otherwise, like if you onboard to DDoS Protection Standard, we guarantee that we will always inspect the traffic incoming to the application and make a very conscious decision of dropping malicious traffic.
All right, excellent. You mentioned how DDoS attacks can often be used as a smokescreen to another type of attack. Can you give some examples of what that might look like? Are people then launching a phishing campaign, or then they already in the environment and kind of moving around laterally and doing privilege escalation? What do you typically see?
Typically, we actually see more of the lateral escalation or lateral elevation that's happening. And DDoS traffic is just sort of a distraction from that standpoint because the traffic volume is so huge. At that time, like any connectivity from the internet is blocked, whereas the hackers are probably like already connected in. And so it's very simple for them to kind of masquerade that lateral escalation that they're doing.
Got it. So would you say it's a best practice if somebody does see a significant DDoS attack to then start maybe doing a bit of threat hunting to look for those type of attacks?
I would say it probably won't hurt, right? Again, depends from a case-to-case basis, but sure, yeah. And that's one of the reasons we also provide the attack analytics and telemetry, so that now you can integrate that with your whatever SIEM systems that you may have to do the holistic, I would say, evaluation and correlation.
Great. Is this service integrated with Front Door as well?
So the DDoS Protection Basic provides protection for Azure Front Door as well. Yeah.
Okay, great. And you mentioned the integration with WAF and ASC. Are we looking at Azure Sentinel integration at all as well?
So the answer is yes. Now, even today, like all these metrics and the attack analytics that we have for DDoS, you can put that in Azure Sentinel and you can do the correlation. Something that we are considering is to offer sort of a very simple connector with Azure Sentinel, such that now, just using like a single click effort, you will be able to pull all those logs and metrics through the APIs. But even in the absence of the connector, you can do it yourself.
Okay, great. Question on the pricing too, and I think you covered this, but I just want to be sure it's really clear for everyone. Based on the way we're charging on traffic, the attacker doesn't have the ability to run up the price at all, even if it's a big attack. Is that correct?
Can you clarify the question? I'm unclear.
Sure. Is it possible for an attacker's traffic to actually, affect how much the user gets charged for the service?
Never. No. So a couple of things here, right? The DDoS pricing, particularly the variable pricing, which is the data process, that happens for the data egress. So from your virtual network to the internet. Now, when the DDoS attack is generated, it's inbound, right? And we're not charging for the inbound traffic anyways. But even during DDoS attack, if, for instance, like amplification attack, there is the pricing that happens because of, because of the amplification attack and the data egress increase, you get the cost credit back.
Fantastic. Okay. On our side, I don't know if this is something you can go into on our infrastructure, but where in our chain are we kind of filtering and dropping this traffic? Is it happening closer to the edge? Is it happening more internally on our systems?
And so it's subjective to like it's happening before your application, right? Because the whole idea of DDoS protection is to ensure your application's availability and performance is not impacted. So we make the determination what's the right place to drop the traffic, but we definitely drop the traffic before it impacts the availability or performance of the application itself. From a user standpoint, like it's completely seamless, right? Like why would you care where we are dropping the traffic? It's not going to have any impact in terms of latency, availability, performance, or even pricing or costing.
Gotcha. Can you add custom header filtering?
Custom header filtering. And how would that help? Like, can you elaborate on the question?
I'm not sure. We'll have to wait for them to elaborate if they want to add more. That was all the question stated.
Okay.
But
yeah, so the answer is not no, and would love to understand the scenario more.
Okay, and that's a great case there where if someone wants to post a more detailed question on our community and kind of lay it out, you can use those links I gave earlier, and I'll give them again in a moment here as when we close up. Next question coming in is, which factors do you consider before blocking an attack?
So there are a lot of ways we actually make a determination whether a traffic is legitimate or not, and if it is malicious. But very few simple examples I would highlight is like, for instance, if it is a TCP attack, right? So the first thing that we do is we try to challenge the clients to ensure that these are the legit clients. There are a bunch of ways we challenge the clients using SYNOD, SYNOS2, etc. But if the clients don't respond to the challenge we are sending, then we drop the connections coming from those clients. We also look at like any common malformities in the packet header. And if we do find any malformities like invalid sequence number, the same sequence number repeating over time, etc., we're going to drop the connections coming from those clients. We also look at how frequently a particular client is initiating the connection. And if it is above or below the norm, we drop the connection coming from those clients. We also have a notion of like source rate limiting. So if we identify that particular clients are generating more connections than they should, then we're going to drop or we're going to throttle the connections coming in from those clients. So again, like a lot of checks and policies and configurations are in place to make this determination in real time. But the gist is that if we do identify that the traffic is malicious, we drop it. And we take all the learnings from like any given attack that has happened in the past as well, right? Like memcached attack that happens, or even the Morai botnet. So we understand like, what were the ports used, how they were used, like what mechanics were involved. We take all of those in consideration as well.
Okay, excellent. The next question we got here is, I see that you were using Ixia breakpoint to simulate an Azure DDoS attack. Is this a free application?
So yes, we are using Ixia, and the reason we are using Ixia is because they have deployed their infrastructure in Azure, which is like completely locked down. So we sort of have control. It cannot go berserk. I think up to like 5 GB of attack traffic is free. You'll have to sign up for it. And I think once you sign up, then for up to 5 GB is free, and after that, like they have kind of a pay-as-you-go model. But I would recommend you to reach out to them, and they'll be able to provide more information.
Okay, great. Can you elaborate at all? You mentioned how it uses machine learning to detect the traffic and to kind of base the judgments there on what it's filtering. Can you elaborate a little bit on that?
So essentially, it's the predictive learning model, where what we are doing is we are learning based on all the past traffic that we have evaluated, and we are predicting what would be the next minute of traffic incoming to your application would look like. That machine learning model again takes 2 things in consideration: the scale of your application, which is the number of virtual machines behind it, and it also takes in consideration the amount of traffic that's incoming to that application. It takes us up to 2 weeks to really build that model and nail it down, such that at the end of the 2 weeks, we have very high confidence in the traffic profile that we have built for your application. So the way it starts is, let's say 9 o'clock today, you enable DDoS Protection Standard on the virtual network. 9, like within less than 5 minutes, the first thing we will do is we'll kind of lower the policy thresholds based on the size of your application, and then some certain understanding with certain heuristics. But from that 9-5 period to the period up to 2 weeks, we'll continuously monitor the peacetime traffic volume. We're going to understand what does that look like. We're going to understand the differences, or like what the variations are. And once we have done that, at the end of the 2 weeks, we'll have like for each public IP, we'll define the application traffic profile. based on which we'll initiate the DDoS mitigation. One very strong recommendation I have is, like, oftentimes I have seen where where customers would go enable or disable DDoS protection standard on the virtual network for a variety of reasons. But anytime, like, you turn on the DDoS protection standard, but after that, if you turn it off, that learning period, once you again turn it on, will start from day one. So we discard that entire learning period. So that is something that is not recommended. So try to avoid it as much as possible.
Okay, fantastic. With that, we are almost out of time here. I'm going to give people some of the links I gave out at the beginning because we had a lot of people join a little bit after the start here. So if we somehow missed your question, or in some of the cases there were ones where we needed a little more detail, you can ask the questions at aka.ms/Azure DDoS community. That's going to take you to our online forums where you can post them in as much detail as you want there. If you're listening to this as a recording after the fact, that's the place you should go to post your question, and we will get to it as quickly as we can. If you would like to give us feedback on these webinars, tell us whether they're valuable to you and what changes we can make to improve, you can give us that at aka.ms/security webinar feedback. If you're looking for the recording of this to pass on to other folks, or just to go review or something, a part you wanted to cover in more detail here, you can find those recordings at aka.ms/security webinars. And while you're there, please join our security community. Let me give you that link here. That is aka.ms/security community. And there you can sign up for our email list. You can join our private preview program, find all these other links. That's kind of the one link to rule them all. And if you are interested in our private preview program, here's the direct link for that. It's aka.ms/security private preview, and that's a way you can get early access to these changes and do any of the potentially, give us feedback on how we should design our product and make changes there. We want to make sure it's as helpful to you as possible, and that we're focused around your concerns and being responsive in that way. So I want to thank Anupam for a fantastic presentation. I want to thank the other members of the product team who are standing by answering questions in the IM window. And most of all, I want to thank all of you for attending and being part of our community. So thanks for joining us, and we hope we will see you next time.